Good afternoon, everybody. Some people from Germany tried to tell you something about how we want to free up the elevator technology and how we want to disrupt a little bit our own industry we are in. We called it the multi. Why we call it the multi, you would see in a couple of minutes. We all know that we are facing a problem, or that we are facing a challenge with urbanization. About 2 billion people will be on this globe in a couple of years. But what maybe not everybody knows is that one Manhattan in volume is built every single day on this earth. So one Manhattan every single day, that means a lot. We heard about Hans, I think you said it already, the density of the city will increase. We will fill up the gaps, of course, that will be the first stage, but then we get higher and taller, and the density will increase. 1/3 of the energy use is used by building, by the real estate. And 10% in a building of energy use comes from the elevators. This is alarming, I would say. Urban mobility. If cities will grow bigger and bigger, denser and denser, taller and taller, urban mobility, mobilization is a big issue. It's about transportation. It's not a singular problem. It's about automatic cars, it's about public transportation, it's about vertical transportation in the building, and it's more than that. It's connecting everything. What we thought as a company, dealing with a couple of things like passenger boarding bridges, so when you enter the airport of O'Hare or others, you might meet us. We are also in the elevator escalator technology and in the home lift technology as well. So I think we have a fair share of knowledge when it comes to elevators. But elevator is not what we were looking for. We have workspace costs, what everybody knows. We call it, let's call it 100. We have 10 times as much for cost for the leasing space. And additionally, we have 100 times of cost for our staff. So if this is all true, and it's not what I'm saying, it's what researchers will say, then office buildings are not as good as they should be, given the human capital we have in there. And same counts for residential buildings, and of course, for all other sorts. In 2010, a university made a research for all Manhattan white-collar workers that over a year, all of them would wait 16.6 years for an elevator and only ride 6 years. This is quite a ratio. And, well, I had the same feeling. I'm staying in another hotel, not in this one, for data protection reasons. When I came from this 27th floor yesterday morning, I had 12 stops to get to the first floor, 12 stops. And 4 were even nobody showing up. So this is, I wouldn't say it's a problem, but this is what we are facing in the industry of vertical transportation, the elevator industry, every single day. And I know that some colleagues of ours are sitting here and they have the same challenge. Now, what we also see is a megatrend of digitalization. I know what you were about to say. First thing, cybersecurity. Okay, cybersecurity is something we have to have a real look on. And we are very keen to make it as safe as possible. We are working with Microsoft Azure Cloud. But the second thing is now the next German company is coming and telling us about connection between software and engines. This is not the case. We are not in the diesel technology. What we do is in the energy part. So HoloLens, for example, is not a playing tool anymore. For us, it's an incremental part of how we see elevators of the future. The HoloLens would provide us with ordering the spare parts right at the site. So somebody is sitting on top of the cabin or in the machine room or whatever, and if he faces a problem, he can call the chief engineer wherever he sits and ask for help. So he doesn't have to go away and come back, and we have downtimes in the elevator. We could solve the problem way easier. And of course, what we call MAX is a little box where we take out all data those elevators will provide us with. This we do with all elevators. But now we are talking about multi. So what is multi? We were thinking about how can we reduce the consumption of space. I'll give you an example. You will see the project a little bit later. In Berlin, we are going to negotiate, or not going, we are negotiating a building which is not very tall. It's Germany, so 140 meters is something. But the density is high, 4,200 people. With a single deck elevator, so a normal elevator, I would say, we would have used 22 shafts to get this frequency up and down. 22 shafts. With a multi, and this is sort of a drama, the multi comes later. With a multi, we came down to 8. So you can see that the thinking about how a core should be and how big a core should be is probably history. We can save at least 40% of the space. It depends, of course, of the building, of the footprint, and all these individual things. But in principle, in general speaking, we has to take care of efficiency. So what kind of elevator would be the most efficient part? I will answer this in a minute. And we need flexibility. A building looks like this today. But who knows how it will look like in 10 years, in 15 years? And what we are going to do then? Do we have to tear it down, or do we do nothing because we cannot? So this is something we have to look at. And at a certain point in time, we invented the twin. 2 cabins in 1 shaft running independently. There are restrictions, but it was the first step to reduce the amount of shafts and to increase the frequency of traffic. A wonderful machine already in place, running for years. But this one, you already know, the Paternoster. What a cool system. A little bit insecure, but it's fun. We have a lot of them in Germany still. They are listed monuments, so to speak. But why are you laughing? It's the old world. And we have something which comes out of consortium. It was a trans-repeat. It was a linear motor technology for trains. Actually, one of those is running in in China, in Shanghai, for 30 kilometers. And the technology was stopped. It was a huge research in Germany, and only Germany can afford to stop such technologies after 15 years of testing. But Thyssen took over all the engineers. How cool is this? So this is when multi comes into play. Multi is the idea of the Paternoster, the idea of more cabins in 1 shaft, and the idea of linear motor technology in 1 piece of technology. It's a combination of what you see here. It's not a rendering. It's the real world. We have it in a tower, which I will show you in a minute, in the middle of Germany, and we're testing it there, and we're going to make the first projects. This is the test tower. By the way, it's built by Helmut Jahn. We are in Chicago, so homage to Helmut Jahn. And if I would have the knowledge which I would have today, then we would have not used a mass damper, and we would have put in a rocket, of course. But instead of this, we took 12 shafts. And this is how the multi looks like today. We love technology. You see that, right? It will be all covered when this thing will be in your shaft, but for testing, it's better to reach to every single part. So the principle is we have multiple number of cars in 1 shaft, depends on the height, up to 10, 15 in 1 shaft. We can go horizontally, so we can take cars away, so the other can pass. We can create highways, country roads, and city roads in terms of traffic frequency. So city roads are slow inter-floor traffic. Country roads, every 5th floor, 8th floor, there is a stop, and the highways goes down in 1 way. And with going horizontal, you can swap those roads. This will increase the frequency rapidly, massively. By the way, this is a mock-up cabin. This is not how the cabin will look like at the end. We are designing this cabin right now. But what you see in the next picture is how it could look like. This is a little bit over-dimensioned, so you need to see a little bit more detail, so this is not the size of everything. But having 4 shafts next to each other would mean that we can swap those tracks. We can make the speed of everything a little bit higher because we can choose on which track we want to have which cabin. So it's a little bit the merger of a train and an elevator. This is why we are struggling to say this is an elevator, because it's not. There is no cable on it. You have seen it already, I guess. So without cable, you can go horizontal. So an architect would say rope, but here I learned so many engineers, so cable. We are not using cable. We are using the linear motor technology, which Markus Jetter behind me, he is a chief engineer for years, and it took over 7 years to get where we are now. And he knows every single screw in this machine. So who can better describe than him? The first project will be in Berlin. Why Berlin? Well, it's in Germany, so the flight time will be less stressful, I would say. But they are not the tallest buildings. So we will see the multi coming up in all those areas you already know, like Asia, Middle East, of course, North America, and Australia. Over to you. You thought I would use 30 minutes, right?
You're perfectly in time. Thank you very much, Michael. And now it's my pleasure, ladies and gentlemen, to give you a deeper insight into the technical world of multi. Many of you, I noticed, have already been in Rottweil into our test tower and see by yourselves what it is about. You could see, feel, almost touch it. And so I'm really sorry that today I have to go back to PowerPoint, as we already reached the point of power. But that's the case today, so I will do it. But there you saw, and if you want to see it, just give me a call, that we have a fantastic demonstration of the different technologies we are leveraging for making multi a revolutionary game changer in people transportation systems. Well, this linear motor technology Michael just talked about is the base for our ropeless elevator system. This is agreed in our vertical transportation industry for decades. We have a lot of experience, yes, in maglev high-speed train, but it is a big difference to realize a smooth propulsion system in a vertical direction. And I'm very proud to tell you that we have achieved a fantastic performance level of levitating, accelerating, move at high speed without noticeable vibration. And with this, we have an ideal individual motion control for a various number of cars. This is proved and available in our test tower. And by introducing a completely new component, the exchanger we call it, we enable the liberated cars to move also sideways and wherever they want to go. The next dimension is available, and with this, an uncountable number of variation of your passenger transportation system in future buildings. You can have the rather simple circulating loop like a paternoster, as we have seen in the video before, or an advanced routing system through your building, including even sky bridges. Can it go also inclined was one of the first questions on our press conference. And Helmut Jahn is very much in favor of this. And I told him, yes, why not? With this type of exchanger, yes, we can do it. Distance control, safety. The distance control and functional safety we have experienced since 15 years. As we introduced Twin in the market successfully. Now we go the next step with more advanced and high-performing safety control components, and control the safety of all cars and all safety subsystems. Energy management. We manage the energy in the best possible level. We use the regenerated energy by cars going down on one side directly within our system, so not giving it back to the grid of the building. We avoid losses by this internal energy management. With this, we manage the smart grid with dramatic reduction of these peak powers. And with this, of course, at the same time, the reduction of connected load and the operation fixed costs. We have a very high redundancy in the system with own energy storage using supercaps. Power failure with uncontrolled stops can be avoided. A word about horizontal transportation. Many of you and the council, the CTBUH, challenged us to elaborate more on the tremendous new possibilities of moving people horizontally. We didn't have that in mind so much when we first designed and researched on this new transportation system. So for this, we did further research and testing in a huge test lab in Germany to find the ideal maximum values for acceleration and jerk. Very important for horizontal movement. Again, ride quality in our elevator business is the highest for all passenger transportation systems. So we can't allow uncomfortable accelerations and jerks. With all today's available simulation tools, and we have heard a lot already today, like CFD, FEM, MBS, and you name it, we check all interactions between building and passenger transportation system. Building sway is no threat anymore for transportation system multi, as we got rid of the swaying ropes. This windy city will love to see less shutdowns of elevators. I think I have a few seconds just for a quick story. The first time I came into this beautiful city of Chicago, it was together with my family. They're not as much touched by elevators and high-rise buildings as I am. So we agreed that they go shopping and to the harbor, and I go to the Willis Tower. I wanted to go up on the highest platform and see this beautiful city, ride the elevators, see how they are performing. I was terribly disappointed. It was a windy day. The elevators have been shut down. I had to come the next day. This should be and can be avoided in future. And we are getting ready for the digitized building business. BIM ready, it's a necessity. We're working on digital twin. We're working on virtual commissioning, all these things which are necessary in addition to such a new transportation system. Just ready for a fantastic future of tomorrow's building with transportation systems that give you the benefit of digitization. Why are we doing this, investing so much on the future? And we are investing really a lot, including this beautiful test tower in this nice city of Rottweil. Why are we so enthusiastic about it? Well, we enabled high-rise building decades ago, 160 years ago. The elevator industry made it possible to have high-rise buildings. Today, we are rather limiting this business, limiting them with our roped systems. So we really want to make a big step toward our customer requirements. They are main requirements. They are constantly coming up to us. Increase your transportation capacity. Decrease footprint and waiting times. Decrease peak power and connected load. And no limits anymore in shape and height. This is what they are asking. This is what we strive for. And with this, I'm closing with our statement, what we stand for and why we are presenting this today. Here on this stage, Multi truly revolutionizes building design, offering total freedom to architects and building developers. Create the best ever places to live and work while improving their business case. Thank you very much for listening.